Hey guys, welcome back to the old mill shed. This is the second video in our basic machining series, and we are covering the outside micrometer. Here are several examples of outside micrometers. I didn't include a digital micrometer because there's really no skill involved in using those. You simply run the anvil and spindle together, zero it, and then it just gives you the answer as to what the measurement is. Now granted, they're great for when you need a little bit higher precision and you're dealing with unskilled labor, or you need to put the measurement into a computer-based recording software like an SPC software. But for most of your small shops, your home shops, this is what you're going to use. And here I have a 0 to 1 inch micrometer, a 1 inch to 2 inch micrometer, and a 2 inch to 3 inch micrometer. And I normally keep these up in sizes to about, I think my biggest one is 15 inches. Even though I rarely use it, there has been several times I've needed one that size. Typically we will use an outside micrometer when we need just a little bit better precision than what a caliper can give us. Calipers typically get us down to the thousandths, and you can arguably say that the dial caliper can get you down to half a thousandths. You know, if the needle's in between two 1,000ths marks, you could basically say, okay, it's, a measurement in 5/10, something like that. But these will get you down to a tenth. So before you use a micrometer, you need to learn the parts of the micrometer. First here, the C-shaped piece is called the frame. You have the measurement faces here and here. This is called the anvil. This is called the spindle. You have a lock lever here to lock it once you get a measurement to hold it. You have your scale, also known as the reading line, and that is on the cylinder. Then you have the thimble, which moves the spindle, and then here at the end you have the ratchet. Now, like here on my Brown and Sharp micrometer, the ratchet isn't out here at the end. It is actually on the thimble itself. And actually this is, in my opinion, more desirable than the ratchet out here on the end. It's just more user friendly, it's more ergonomic, at least for me, to have the ratchet built into the thimble. So using a micrometer is very, very simple. In some ways it's not much different than using a set of vernier calipers. But the first thing you want to do when you pick one up is first clean it using the note card trick like we learned with the calipers, and then you want to check your zero. And the note card is clean. So we're going to run this up. And I'm not exactly on zero, and I know this caliper measures small. And if I go to my vernier scale, and we're going to learn that here in just a second, it is reading 8/10 small, which this micrometer usually runs about 2/10 small. But that's at around 50, upper 50s, lower 60s. It's about 34 degrees in here today. And I'm sure that this frame has shrunk a little due to the cold, to the temperature. And that's why it is reading a little smaller than normal. These larger calipers do not allow you to run the faces together to clean them. So what I will normally do is I take eyeglass, the wipes, like that little cloth that you clean your eyeglasses with, and I will clean off each one of these faces, and I will clean off the face of my, see if it'll focus here. I'm using two cameras here today, guys. I'm having issues with my main one. I have a 2-inch master here, a standard, and this is supposed to be 2 inches at 20 degrees Celsius, which that's about 68 degrees Fahrenheit. So once you have everything clean, you put your standard in here. And you just run the spindle down on the standard. And this one's reading slightly large. I am reading 1/10 over. So this micrometer is reading 1/10 larger than the standard. Now in a home machine shop, 1/10 usually doesn't really gain you a whole lot, but it is nice to know what that offset is. Now I apologize for having to use a whiteboard for this. I tried to get the cameras to focus in on the little marks of the micrometer, and it just would not work out for us, so here we are. So to read the micrometer, like I said, it's not much different than using a vernier caliper. My super high-tech pointer here. So if you look on the barrel of the micrometer, you'll see you have long lines with a number above them, and you will have 3 short lines in between them, with the center of those having a little tick mark above. Each one of these lines is 25 thousandths. Each one of these long lines is 100 thousandths. Now the thimble here, what it does, it has a mark every thousandths, and every 5th mark will have a number associated with it. So if this thimble is rotating this way, the numbers are progressing in this direction. That is 7 thou, 8 thou, 9 thou, 10 thou, 11 thou, and it will go all the way around from 0. Well, 0 and 25 thousandths is the same number. So it will go from 0 to 24, and then the 25th division is 0 again, because that is your 25th thousandths marker here on the barrel. So to read this particular one, we're past the 300 thousandths mark. We're past the 25 thousandths mark. We haven't made it to the 50 thousandths mark, so you're somewhere between 325 and 350 thousandths. And you're sitting on the 10 thousandths mark. So 325 thousandths plus 10 thousandths gives you your 335 thousandths. Then you will flip the micrometer over to the back side here. I don't know if that'll focus in on that or not. And you will have 0, 1 through 9, and then 0 again on the back side. And that 0 line and this 0 line will correspond. So if there is a mark lined up on this 0 line, there will be a mark lined up on that 0 line, on the one on the back side. And you see here that a thousandths mark is most closely lined up with the 2. And one of these marks over here will only be lined up with one of these marks at any one time. So this tells us that this measurement here is 2/10 over what it is reading there. So it becomes 335 thousandths 2/10. Okay, so I got us a few things we can practice measuring here. Just dug these out of the scrap metal bin. So I've already cleaned these. We'll do it again. Yeah, these are starting to warm up. They are only 4/10 large now, where we were 8/10 larger earlier. So let's just measure this old, I don't know what this thing was, hydraulic shaft maybe? Who knows? So what you want to do, you want to barely get to where it just barely drags at the largest diameter. Just barely, don't put any pressure on it whatsoever. That's it right there. And we have, yeah, this is right at the 1 inch mark. We have 975 down here on the reading line, and we have 975 plus 20 is 995, 96, 97. Now we're between the 97 and the 98. So this will be 997 thousandths. And we are at the 5/10, and we know that we're reading 4/10 under, so we want to add 4/10 to that. So we are at 997 and 9/10. That's the diameter of that shaft. You can also check the how out of round a piece of material is if you want it to. Now you just got our standard here. And what you do is you want to rotate it 1/4 of a turn, no more than 1/2 a turn. Because anything after that, you're just measuring the same distance, just in the opposite direction. You're not really gaining anything. And I'll usually do it 4 or 5 measurements in 90 degrees. So right here I have 314 thousandths, 5/10. Let's write that down. Get started here. Turn about a 1/16 of a turn. 314 and 4. .314 and 9, 315 and 2. So our largest diameter was 315 thousandths and 2/10. Our smallest diameter was 314 thousandths and 4/10, which gives us an out of round of 8/10. You can also check the internal dimensions of a part with an outside micrometer by using a telescoping bore gauge or a set of inside bow calipers. The man that taught me machining used these a lot. He was actually a machinist's mate on an aircraft carrier during World War II. And if you needed a bearing, put into a plate, you could give him the bearing, tell him you want it to be press fit or slip fit, and he would measure that bearing with an outside bow caliper, set his inside bow calipers off of that, and start machining it. And if you wanted it slip fit the first time he would try it, it'd be slip fit. If you wanted it press fit the first time he'd try it, it'd be press fit. Of course, that whole generation of machinists was much more capable than most in my generation. We obviously stand on their shoulders. Not ashamed to admit it. I will never be the machinist that most of those old men were. But anyway, how you do this is, say you've got your telescoping bore gauge set here, and we'll go over how to use these in a different video. But you just take your micrometer and you just rock it back and forth, because you know they have a domed side on each, a domed end on each side. You get it where it just barely drags right there. Let me get my glasses here and we'll read this. We are at 575 thousandths plus 2 cents. We're at 577 and 3/10. And then this thing is reading 4/10 small, so 577 and 7/10. Now I actually measured the inside of a piece of pipe with this one. See, this is going to fit this one. Yeah. It's the same thing. You just have to be careful that you don't collapse that spring. There you go. And we are at 915 and 4, so 915 and 8/10. So that's how you can measure an ID using an OD micrometer. Hey guys, well, that's the video. I hope you enjoyed it. If you did, hit that thumbs up, subscribe, and hit that notification bell. It helps the algorithm a lot. We'll see you here next time under the shed.